So here in session 2, we can see how we can going to create a logical volume manager. So what is logical volume? Logical volume are nothing but those particular partition which we change into a manageable partition. Normally what happens, the normal partition, if we create the standard partitions, cannot be renamed or cannot be resized. We cannot extend the partition, we cannot reduce the size of the partition, but LVMs allow us to do that. So we are going to see it practically. So for that, I'll just move into our terminal and we'll move into our hard disk now. Before moving into hard disk, you should also know the packages required for your LVM. Normally, by default in Red Hat, you have texture mode LVM installed in our system, that is a base mode. If you go for graphical, you need to install the package system -config-lvm. But here generally we'll just check whether the partition is available by using rpm space -qa, that is query all grep and then lvm. So grep, we can see the LVM is available. Now we are going to start with our LVM. So for that I'll create one partition, and side by side graphically we can even check what are the changes happening after we creating the system, partition as your LVM. So I'll just start my disk utility side by side, and I'll move into hard disk. These are the partitions which we have created in earlier session. So I'll create one partition in this free space /div/stb3 or stb. First I'll create a new partition and enter. I want to create a primary partition, so p, enter, and then it will ask me the space I am going to create the partition. It will ask me which space you require, so I am taking the free space. So p, we will define, enter. So which name you require, which number you require, so I'll just use 3 as default one. Then sector in size, so 10 GB I have defined, but I think it's out of range, we don't have enough space, so I'll define 8 GB in spite of 10 GB. So it has been taken. I'll save it by W. W means your save and write the table into partition and quit. So I'll just quit this partition. Right now, we know this partition has been created, so we can format this partition ext4/div/sdb6 KFS. Sorry, it's SDB. We need to define the partition, otherwise it will format the complete disk. So I'll just press no and can give command SDB6 or SDB3. 3 actually it is not recognizing, it is not updated. So in spite of that, we can use 6, which is again a logical partition in our disk. It's there, but it's not updated. In spite of, I'll use SDB6. 6, enter. So it will format SDB6, right? So before starting with creating LVM, we need to change this partition into a volume. For that, first of all, we need to change the type of the partition. So for that, I'll move in your F disk. I will move in the hard disk. I'll enter. Now I need to change the partition type to your Linux LVM. So for that Linux LVM, the list we need to check, that is we can press L and we can check the list of partition. Here we have for LVM, we have 8E. So we will be using this 8E here to change the volume to LVM. So for changing the type, we will use T, enter. The number of the partition 6, enter. And then it will ask which particular file system type you require. So I need 8E. So I'll define 8E and enter. So it will give option that is been changed to information LVM. So LVM has been changed. Now move out by pressing W. Now we will just check into the hard disk whether this partition has been changed, right, to LVM. Now I'll clear it out, and then we will just do one thing. will create this partition as your volume. For creating your partition as the volume, we require to give command pv create, that is physical volume create. Which partition you want to create as a physical volume, /dev/stv6. Now it is asking you if you have further any particular data, old data, it will get deleted if you format do the same. So I told okay, you can wipe the data as we have nothing in that particular place. Now physical volume has been successfully created. Now we need to move inside this disk. Before that, I have to create a volume group. So for creating a volume group, I have command vg create test space /dev/sd6 and enter. So it will be created volume group with name test on your dev/sd6. So this particular partition will be named as test from now onwards. It is successfully created. So this is a group inside which we are going to create our logical volume, that is LVs. VG display, we can check with the name how many VGs we have. So it has been created in your volume 1, hard disk 1 also. So it is showing you the RHL name volume group has been created. Our volume group is test. Now we can check that test also. You can even directly give VG display test. So if you have a particular test name VG, so you can get the information of it. So it is showing you LV which is created, open, maximum LV, current LV. So we have not created an LV. So it is not showing you as the references. So we need to create an LV first. So for creating LV, we need to give command LV create. Can even check in graphical mode. Partition 6, you can see this in LVM2, right? So because we have used partition 6. Now remove disk utilities again. Can check F3. So free space is still available, which we can use later on for extending our VG. Now you can see that LVM2 is provided in your first hard disk because it's also have LVM partitions. Like this, other LV is created on this particular partition, that is volume group. Now here again we have LV on partition 6, here LVM2. Now I am going to create partitions, LV partitions in my VG, that is here VG which we have defined yet, that is test. So we will create a volume, logical volume with name volume group inside this particular group. So that will be your PV created. Same here, PV is created. I'll create LV group by giving command PV create space -n. We can define the name of your logical volume PV create. Hyphen. First of all, we can even define the size by using -L. -L, capital L, this is case sensitive. So you can define the size by using plus. You can define size into parameters GKM, and that is name, what the name you want for LV. If you don't define name also, it will go for VL vol 0. If I want to define my own name, so we can define the name as LV1, okay, LVM1, and which LV you are using, your volume group you are using. So I'm using test because we have two different logical volume groups, that is test and RHC, which is there previously we have created in our other disk. So now we have created a LV also. Now you can see in partition 6 you can't find anything. That will be created, and once you mount it, you will be able to see this one. But in command, you can see VG display, you have created one physical volume, correct? Current volume, logical volume is again 1. So one logical volume has been created, right? So now what we need to do is, we will see the display of the information about your LVM, which is created under your test. So you can give command /tape/mapper/test, or we can even give test/lv1, right? So you can see LVM1 has been created under test. Name LVM1, name as test of your volume group, right? So now I am going to format this logical volume which you have created. So mkfs.txt4 space /tape/ or directly you can define test/lv1, however you want, you can define it. So whatever the volume group you create, logical volumes you create, by default it moves under your mapper. The default location of this is mapper, that is located again in your div. So /test/lvm1, you can format it mkfs/div/test lvm1. So it has been formatted. So you can see it's not mounted yet, but it's formatted. So for mounting it, again you can mount it in a location so that I can use this partition, same as your partition which we have created. So you can give command mount. Right, so it is formatted again. LVM is formatted. Go to file system ext4. Now for mounting it, I'll mount it by using mount/div/sds test/lvm1 space /mnt/ or you can directly define mnt right now. There is nothing is mounted. cd mnt. You can check your ROS test float is over here. You can create a folders. Test drive, any particular folder you have created. So I've created test drive, and we can mount the same by the same method. Enter your source or destination address. Now you can check in graphical menu, partition 6, LVM2 has been created, that is PV, and your mapper test, you have LVM1 created, and you have saved the data over here, but you will not be able to see what is the data you have saved here. So we need to mount it. Or if I want to extend the size of this particular volume, for extending the size, we have command lv extend space -l plus what the size you want. I want just 5 MB to be increased, or 50 MB to be increased. And which particular logical volume you want to extend. So I need to define the complete command. So I've defined 500 MB /div/sdb1. SDB. You need to define the LV space. So LVM1, enter. So it is resized. You can see it has extended to 2.49 GB. So we can check the size again. It is 22.7 GB now. I can even check in command line mode. We can give command lv display. We can mount the data again with the same ID, and whatever the data we had, we should get that data back. Same MNT I can mount. ls. There is no loss of data. You can see whatever you created, it is there. You can see how we can reduce the size of it. We will reduce by using command lv reduce space -l. Now for reducing it, in spite of minus plus, we will use minus sign so that it will reduce plus 1 GB from /div/test/lvm1. enter. It is asking you if you have kept any data, it will be deleted. I told yes, it will do. It is successfully, the space is successfully removed and it is resized to 1.6 GB. Right? Now I want to display again in your test mode. In text mode, again it is showing you one logical volume, current logical volume, extendable size is this, and other details. Right? Now we can even remove the LV. So removing LV remove /dev/test/ your LVM name, that is LVM1. So it is showing it is in use because we have mounted it. You can check in a df space -s. So you can see the mapper is mounted in MNT. So you mount it by giving command umount. Then create a forfeit, you can try to remove it. Start terminal again and we'll try to remove it. It's been mounted, so we will just update the partition table so that whatever changes we have done, so it will be saved to it. Again I'll give command lv remove /dev/test/lvm1. /dev/stb LVM. It is mounted, so it is been backend. There are some services which has been mounted. So I'll just give command dev/test/lvm. Now we can again format the same, or try. Yes, it is formatted. That means now it can be removed. So we will give command lv remove dev test lvm1. So it is asking you for confirmation. Yes, and enter. So it has been removed. Now you can check LV display or VG display. There will be no LVM again here. Then we need to clear the screen. We will try to remove your VG. So VG remove space /dev/test. So if you have your LVs, more LVs here, you won't be able to remove your VG as well. So first, for removing VG, you need to delete all the LVs. Then you can remove your VG. Now we can check in our disk first. You can check here that it is already started. So we'll just see the LVM is still there, but the partition which we had, that is removed. So for moving this system from your PV, that is physical volume, to again partition, we need to give command PV remove /dev/test. Enter. So you can check the volume. The physical volume should be removed and it will be changed into a formatted 83 partition type cell system. You can check the partition is showing unknown because we have not formatted this partition yet. So I can format this partition, so it will make it my unhealthy partition to a healthy formatted partition. This is how we have seen how we can manage our LV. Now in next presentation we will see how we are going to manage our volume group.